Hey guys, welcome back to my channel. Today we are looking at GCSE Chemistry topic 9, Chemistry of the Atmosphere. Before we jump into it, please subscribe, especially if you want to check out some more GCSE Chemistry videos, and comment below any questions you may have, and either myself or your fellow students will come and answer them for you. And yeah, feel free to like as well, recommend these videos to your friends if you find them useful, etc, etc. But let's just jump straight in. So firstly, looking at the composition and evolution of the Earth's atmosphere. So for 200 million years, the proportions of different gases in the atmosphere have been pretty much the same as they are today. So roughly about 80% nitrogen, 20% oxygen, and then small portions of other gases such as carbon dioxide, water in its gas form, and noble gases. Obviously, you're probably aware that the theories of when the Earth started and how it started vary a lot, but so essentially the evidence is limited for the Earth's early atmosphere because of the time scale of 4.6 billion years, and theories are just constantly changing and developing. One theory, which is the theory that you only really need to know, suggests that during the first billion years of Earth's existence, there was intense volcanic activity that released gases. So at the start, the atmosphere may have been like that of Mars and Venus, mainly CO2 with little to no oxygen. Volcanoes also produced nitrogen, which gradually built up in the atmosphere, and there may have been small portions of methane and ammonia. Then water vapour condensed to form the oceans. CO2 dissolved in the water and carbonates were precipitated, producing sediments, reducing the amount of CO2 in the atmosphere. Just realised I forgot to close that bracket off. Oxygen increased through its production by algae and plants via photosynthesis. You've got the little equation for photosynthesis there, where algae first started producing oxygen 2.7 billion years ago. Over the next billion years, then plants evolved and the oxygen levels increased to a level that allowed animals to evolve. Then algae and plants also reduce CO2 via photosynthesis, so obviously you can see in the reaction that CO2 is one of the reactants, as well as the formation of sedimentary rocks that contain carbon, for example, limestone and coal, and by the production of fossil fuels from the remains of dead plants and animals when they decay. Then looking specifically at carbon dioxide and methane as greenhouse gases. So greenhouse gases maintain temperatures on Earth high enough to support life and include water vapour, CO2, which is carbon dioxide, and CH4, which is methane. The greenhouse gas effect, so electromagnetic radiation at most wavelengths from the sun, passes through the Earth's atmosphere. The Earth absorbs some radiation and so warms up, but some heat is also radiated from the Earth as infrared radiation, some of this which is absorbed by greenhouse gases in the atmosphere, which then warms up and leads to the greenhouse effect and global warming. Human activities increase the levels of carbon dioxide and methane, so examples of this activity include driving, using electricity, maintaining livestock, as well as the decay of organic waste in landfill. Based on peer-reviewed evidence, scientists believe that human activities will cause the temperature of the Earth's atmosphere to increase at the surface, resulting in global climate change, but it's difficult to model such complex systems, and so we end up developing simplified models which can be biased and do not express the full story, hence why sometimes the media isn't always the most trustworthy when it comes to this, because it always tries to simplify it. An increase in average global temperature is a major cause of climate change, and potential effects of this include species extinction, raising sea levels due to melting polar ice caps, migration away from areas of flooding or drought, and a decrease in crop yields for all major crops that we as humans use. Then you have carbon footprints. So this is the total amount of CO2 and other greenhouse gases emitted over the full lifestyle of a product, service, or event, which can be reduced by reducing our CO2 and CH4 emissions. For example, we can use less electricity, reduce our travel and actual transportation, whether that be us as humans or how we transport vegetables, products and things, and also by planting more trees. Although making these changes can be difficult, they can often be more expensive, and also planting trees requires a lot of land, excuse the noise, and it takes away land from crops. Then we have common atmosphere pollutants and their sources. So combustion of fuels is a major source of atmospheric pollutants. So most fuels contain carbon and or hydrogen and may also contain some sulfur. And the gases released into the atmosphere when a fuel burns includes carbon dioxide, water, carbon monoxide, and oxides of nitrogen. Solid particles and unburned hydrocarbons may also be released, forming particulates in the atmosphere. If there isn't enough oxygen, some of the fuel doesn't burn. This is partial or incomplete combustion, which we discussed in a previous video, where solid particles of soot, carbon monoxide, and unburnt fuel are released. The combustion of hydrocarbons releases energy. So during combustion, the carbon and hydrogen oxidize to form carbon dioxide and water. Now looking specifically at some of these pollutants, so carbon monoxide is a toxic gas which is colourless and odourless, so not easy to detect. Then you've got sulfur dioxide and oxides of nitrogen. These cause acid rain and respiratory problems in humans. And particulates cause global dimming and human health problems. So that is everything in today's video. Please let me know if you have any questions at all. Just comment them below and either myself or your fellow students will get to them. But yeah, please again feel free to subscribe, like the video, and I shall speak to you soon.